Anybody have any kind of just general questions about the test or anything before we start doing the review? Can't think of anything. The formula sheet that I will give you is on Canvas. It's down at the very bottom on modules, I think. So you'll know what to expect on the formula sheet. You don't have to print it or anything. I'll give you a copy on test day. And then I'll give you whatever pages out of the binomial tables you may want to use as well. If there's anything else I can think of. I guess that's it. All right, so all I've done is I've printed out one version of the practice test off of Hawks, and we'll work through all of those problems so you'll have at least one example of everything on the practice test. No questions? All right, quite a bunch today. All right, look at the first one. Okay. Gives us some data, got the ages of a group of people. It says determine the graph that correctly represents the data. Probably zoom out on that one a little. Okay. Might be a little hard to read the numbers, especially if you're in the back, but anybody, we'll call that 1, 2, 3, 4. Okay, I got to vote. What do you think?
Is it number 3?
Number 3, yeah, I think it would be number 3. Okay, it's not the first one. Not this one, because it doesn't match up with the data in the table. It's not the last one. Why is it not that last one? Yeah, it's not a histogram, it's a bar graph. Okay. So not that one. It's not number 2. What was wrong with number 2?
It doesn't have labels or title.
No labels or title. Okay, so that leaves us with graph number 3 there. Okay. Here's our proper graph. Nothing too difficult on that one. Questions on? Okay. Number 2, got a stem and leaf plot. And it tells us on our key, stem of 9, leaf of 1 represents 91 pounds. Okay. First one here asks us what's the weight of the lightest person. 91, yeah, because there we've got a stem of 9, leaf of 1. That gives us our smallest combination, so 91 is our lightest person in that group. Number 2 says how many people weigh in the range from 130 to 150 inclusive. So the inclusive part means if you have a 130, we're going to count it. If we have a 150, we're going to count it. So we just count the leaves. Right? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. The next person's 152, so that's too big. So we get 9 there. Okay. Common mistakes I see there is sometimes somebody just won't read it real well, and they'll like include this row too, but just read it carefully. Okay. And then 3 says what's the weight of the heaviest person in the range, 120 to 129. Yeah, 124, good. So in the range 120 to 129, that's going to be this row. So our heaviest person there is a 4, so we get 124. Read stem and leaf plot, you're in good shape on those. Any questions on that one? Can't think of anything? Okay. I am screen recording this. If you run into anything you need to go back to, I'll have it posted. Okay. All right, number 3 gives us some data. Tells us find the mean, median, and mode. So we'll start with the mean. Okay. How do we find the mean of a data set? Add them all up, divide by how many we have. That's right. So let's see on this one. We've got 9 plus -10 plus -7 plus 11 plus 1 plus -4 plus -7. There I get -7. And we've got to divide by 7 on this one. So we get -1, and if we're being real particular, I'd say -1.0. But yes.
Can we use a calculator on the test?
Oh yeah, absolutely. Yeah, we're supposed to have a calculator with statistical functions, so bring a calculator. Okay. Yeah, absolutely. Okay. Questions on finding the mean? Okay. Number 2, or step 2, says find the median. What we got to do to find the median? We got to put them in order first, and then we want the middle number. So here we have some negative numbers, so be careful with those. Our smallest number is -10, and -7, -7, -4, 1, 9, and 11. Is that all? 1, 2, 3, 4, 5, 6. Okay. Then, yeah, we're looking for the middle. This one, our middle value is -4. What if we had 2 numbers in the middle? Add them up, divide by 2 if we've got 2. That's right. Okay. And number 3, we're looking for the mode. -7's on there twice. That's more than any other number. Our mode here is -7. And I'm not going to ask unimodal, bimodal, multimodal. If it has no mode, you need to say no mode. But on this one, just because it's there, okay, we have 1 mode, so this one is unimodal. The way I will know that it's unimodal is if you give me 1 number for the mode. Okay. Questions on mean, median, mode? Okay. Oh, sorry. Number 4. Okay. Says if you draw a card with a value of 5 or less from a standard deck of cards, I'll pay you $49. If not, you pay me $26. It tells us aces are considered the highest card in the deck here. If you don't know the cards in the deck, I'll probably put them up on the board, and if I forget, just remind me on test day. So if aces are the highest, okay, there are our cards in each suit. We've got 4 suits, and so we've got 4 of each of these cards. And the reason why we need to know that, 1 says find the expected value. So we need to make a little table. We've got 2 outcomes. Either we win $49 or we lose $26. And then we need to figure out the probability of these. That's where the cards come into play. Okay, so when do we win? It says if we draw a card with a value of 5 or less, and we win. So how many of those do we have? We've got 1, 2, 3, 4 in each suit, but we've got 4 suits. 4 times 4, we've got 16 winning cards in the deck out of 52 cards in the deck. And then how do we get our other probability? Yeah, it's the rest of them. So either you can count them if you want to, that's fine. We can also do 52 minus 16 gives us 36 out of 52. So let me move this over. So we're ready to do our calculation for expected value. We take each outcome, multiply it by its probability, and add them up. Here we've got 49 times 16 out of 52. And then negative 26 times 36 out of 52. See what we get there. I should have brought my good calculator. Somebody punch it with me if you've got yours, so we'll make sure we get the same thing. I got negative. That's what I got. Negative $2.92. Good deal. That sounds about right. That's it. That's all this one asked. I took out the other step where it asks if you do it multiple times. It's easy. You just multiply. So big deal. Questions on any part of that one? That's one of the more involved ones because I have to make that table. Okay, I'm getting the probabilities and getting that table set up. All right. Number 5. We just got some of our vocabulary here. It says identify the population. And we're given the high school GPAs of a sample of 22 professors at the local college. So what would our population be for that data? Yep, yeah, all the professors at the local college. So the 22 that it's talking about is our sample. Yeah. B is just too big. This is the high school GPAs of everybody in the U.S. That's just more general than we're being here because all our data is coming from the local college. Okay. So the group of people we're studying here, the population, all professors at the local college. Where the population is the big group, we take a subset of that, that's the sample. Question on that one? 6 tells us to decide if we are given a population parameter or a sample statistic. It says the average price of a house in the new subdivision is $318,000. So there we have to think about what our population would be. So our population there is just all the houses in this new subdivision. It doesn't say anything about taking a sample. So is this number telling us about the whole population or about a sample? We don't have a sample anywhere in there. Yeah, this was a little confusing because it doesn't mention anything about a sample. So this one is telling us about the whole population. In order for it to be a sample statistic, it would have to say like, you'd have to have some information about a sample in there, like 10 of 50 houses, the average price of 10 out of the 50 houses in the new subdivision, something like that. You'd have to have some information telling you about a sample that was taken in order for it to be a sample statistic. Questions on that one? Anything I can do to help make it more clear? Sometimes they're a little confusing when they don't mention a sample. Okay, we got a little Data classification here. 7 says genders are an example of which type of data. So we have a kind of a pre-question we need to ask ourselves here. Because this is asking us, is it discrete, continuous, or neither? Before we get there, we need to think, is this qualitative or quantitative? So gender, would that be qualitative or quantitative? That one's qualitative, that's just a label. Gender, just a label. So what about discrete, continuous, or neither? If it's qualitative, it's always either. It can't be either one of the other two, right? These two only deal with quantitative data. And gender is qualitative. I think we've got another problem where we'll talk about the difference between the discrete and continuous. So. Okay. All right. It's qualitative, can't be discrete, can't be continuous. All right. Number 8, ask us about the shape. So what shape would that distribution be? Okay, for sure. Are they low early? They normally do that on test day, or 2 days early today. Okay, so we're for sure skewed, and it's skewed to the right. Okay, skewed to the right because the skinny piece is on the right. Skinny piece is on the right. Okay, so this one's skewed to the right. Uniform as if they're all about the same height. Symmetric as if one side looks like a reflection of the other side. And skewed to the left would be the opposite of this, right? We'd have the skinny tail on the left side and most of the data would be on the right. Those are the 2 hard ones to tell the difference between harder, just remembering which one's which. Questions? Yes. Well, I'd have to have an idea of what kind of shape you're thinking. Really tall one. Yeah, you could have something like that. These are our 4 basics. Right? We would probably, if you had like a really tall bar over here, we'd probably actually lean more toward it being symmetric. Because then we'd have a big tall bar over here and we've got some tall bars over here. So it's really just, there's gray area. Okay? These are our 4 basics, and then there can be some borderline cases where it might be one, might be the other, but yeah, we're not gonna have anything tricky. Okay. That's a good question. Okay, number 9. Stuff like that comes up in practice less than you think it would. Okay, number 9 just says calculate the population standard deviation. I cut the other ones out, the range and the variance. Okay, so this is a calculator problem. And I didn't bring my good one with me. Anybody got it? So the one thing to talk about here, since it says population standard deviation, is this going to be S or sigma? It says population out of your calculator, you got to know which one. It's going to be sigma. Just sigma because it's standard deviation. If it's variance, then that's when it's squared. Yeah. So what do you got? Okay, 4.1 there. Anybody else try it? I forgot to bring my stat function calculator. So you haven't learned that yet. Okay. Need to do that for Thursday. Okay. So on your calculator, if you have statistical functions, there's somewhere in there where you can just put in the data, okay, and then tell it you want standard deviation. You got to know which one you should be using. Okay, this one said population, so it was sigma. If it says sample, it's going to be S. Okay. Okay. Calculator problem there. And the way we rounded, set around to one more decimal place than we had in our data. So they were whole numbers, so we left one with our standard deviation there. Questions on that one? I'm not going to ask for variance. I'm going to ask for standard deviation. Okay. Number 10 says suppose diameters of a new species of apple have a bell-shaped distribution with a mean of 7.25 centimeters, standard deviation of 0.42 centimeters. Using the empirical rule, what percentage of apples have diameters that are between 6.41 centimeters and 8.09 centimeters? The goal of this problem is to see if you remember the percentages from the empirical rule. Okay, I'm not going to give you a really hard one, like the real tricky ones where you have to use the symmetry and do subtracting and adding and all that stuff. I'm going to give you one that just asks for between. So here we just need to figure out between what? Between how many standard deviations. So we make our sketch. Our means at 7.25. 0. All right, so it said our standard deviation was 0.42. So 7.25 plus 0.42 gets us to 7.67. That's one. Go up another one, so plus 0.42 again. At 8.09, so that's as far as we have to go on that one. We're going up to. And do the same thing going down. So if we do 7.25 minus 0.42, we get 6.83. Subtract another standard deviation, so minus 0.42, we get 6.41. Those are the two numbers we're looking for. So we want to know what percentage of our data is between minus 2 standard deviations and plus 2 standard deviations of the mean. What percentage is that? 95 that way, yeah. So we got look at those. We got 3 percentages to remember. Okay, we got, yeah. Within 1, we've got 68%. Within 2, we've got 95%. And within 3 is the hardest one for me to remember. We've got 99.7%. And if you do it, if you want to do this in the way Hawks does it with the Z-score formula, if you did the instruct or the tutor on Hawks, that's fine too. Okay. Fine too. So what I'm saying is on Hawks, it would show you to do 8.09 minus the mean divided by the standard deviation, and there you would get 2. Okay. And then you would do 6.41 minus 7.25 divided by 0.42, and you would get -2. That's fine if you want to do it that way. Okay. Now that we've talked about that Z-score formula. Either way, it's good. Realize that negative is so bad. Questions on that one? Again, I'm not going to give you a really hard one or anything. So. If you get the general idea of figuring out how many standard deviations you want to be from the mean, and then you remember the 3 percentages, you'll be in good shape. All right, number 11. Let's calculate the 5-number summary. I got them in order already. Okay. That's a lot of numbers, have to reorder. So 5-number summary, what numbers are in there? That's one thing we got to remember. We want the min, Q1, Q2 or the median, Q3, and the max. Five-number summary. So start with finding the median. Too many numbers for me to be able to just look at, so. I done 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. Okay. So we got one number in the middle. I think, let me double check. Yeah. And what I'm doing, double checking, is I'm counting how many I've marked off on each side. It should be the same. So I've got one number in the middle, 14. That's the median. Okay, so then we, hang on. Lost my bar up here. Then we split it. Yeah. Since we've already used 14, we leave it out. Okay, so find the median of the lower half. That's Q1, 8. Find the median of the upper half. Q3, that's 19. And then the minimum's 1, maximum's 24. Okay, so our 5-number summary, you don't have to label each one. That's not a big deal. We just need the 5 numbers. So 1, 8, 14, 19, 24. Yes. Sorry. Yeah.
So
If you have an even amount, so like if these two were the middle ones,
Yeah.
then we would split it right here. Yeah, you leave them in. The only time you leave one out is if it's exactly in the middle.
Okay.
Yeah. You're welcome. Good question. What I was forgetting to mention that. Okay. Other questions on that one? Okay. You gotta remember what 5 numbers are in the 5-number summary. That's important. So I get all kinds of stuff on that. I get some really interesting numbers sometimes on 5-number summary, but we want the Q1, Q2, Q3, or Q2 is the median, and then the minimum and the maximum. Okay, number 12 is find the expected value of x. So expected value is formula on the formula sheet, but all we have to do, okay, we take each outcome, multiply it by its probability, add all those together. So here we'd have 3 times 0.2 plus 4 times 0.2 plus 5 times 0.2 plus 6 times 0.1 plus 7 times 0.3. See what we get there. See. I got 5.1. Anybody else try it? Let me know if you get the same thing when you get there. Anybody else get 5.1? Okay, good deal. Good deal. Okay. Hard from on the phone calculator is hard to scroll back through and see what you typed, so it's hard to double check. Okay. That's it on that one, but the formula is on the formula sheet. The formula says it's the sum of x's times probability that x equals x. Okay. That's all it's doing, the same thing we just did. Okay. Questions on 12 before we leave it? 13 says certain insecticide kills 60% of all insects in laboratory experiments. A sample of 9 insects is exposed to the insecticide. What's the probability that exactly 1 insect will die? You do have to be a little careful on those. I'm not going to try to trick you, but here it kills 60%. We want to count the ones that die. So this is binomial because an insect either lives or it dies. Okay. So no matter what method we're going to use, we need NP and X. Here we're doing our experiment 9 times. We're testing it on 9 insects. For the probability of success, for success, we're counting the ones that will die. So probability of success is 60% or 0.6. Some of the ones in hawks, sometimes they throw you a little bit of a curve and they'll say it kills 60%. What's the probability 1 survives? And you got to flip-flop the percentage there. And then we're looking for exactly 1 to die. Okay, so our choices, we can use a binomial table, and it's just the standard binomial table because x is exactly equal to something. We can use the formula, which will be on the formula sheet if that's how you've been doing it. Or you can use the function on the graphing calculator or whatever calculator if you have that. Just remember, if you use just your calculator, make a little note on there and tell me that's what you did. Okay. I'll look this one up in the table here. So we need n of 9, p of 0.6, x of 1. I should have had this pulled up already, sorry. We'll see how slow the internet is. Okay. So n of 9, p of 0.6, x of 1. Go to the binomial table, n of 9, p of 0.6, x of 1. So there I know small is 0.0035. Just the standard binomial table. Get 0.0035. You should get the same thing if you do the formula or if you do it with the calculator function. And other than you have to round. You have to round to 4 places if you do it that way. Questions on that one? So like if that one was on the test, you would have this page out of the tables. And you'll have the n equals 9 page. So you can do it that way. You can do it with the formula. It'll be on the formula sheet, or you can do it with graphic calculator if you have that. Any of those is fine. Good. Okay. 14 says a student takes an exam containing 13 true or false questions. The student randomly guesses on the entire exam. What's the standard deviation of the number of incorrect answers? So before you jump into the standard deviation part, look at what kind of data we're dealing with here. They're true or false questions. So we only have two possibilities. So we're dealing with a binomial distribution. So on the formula sheet, we'll have the formula standard deviation of a binomial distribution. That's this, n times p times 1 minus p, and then we take the square root. So we need n and p, and sometimes on one like this I'll have people panic because there's not an x. You don't have to have x to get standard deviation. Okay? We're not looking for any particular number of successes, we just want the standard deviation. So n, we've got 13 questions, n's 13. And then sometimes I have people freeze up on getting P on one like this. If it's a true or false question and you're guessing, what's the probability of success? 0.5 or 50%. And you only got two choices. Okay, so then we just plug in. And then it says round to 2 decimal places. There I get 1.80. Somebody else check it. Got the same thing? It's like 1.8027 something. Questions on that one? 15, got another vocabulary problem. It says decide if we're looking at a descriptive statistic or an inferential statistic. It says the average price of a house in the new subdivision is $345,000. Okay. All this is doing is describing the data. So this one is a descriptive statistic. Okay. Remember, inferential statistics have another step in there. Okay. So an inferential statistic uses descriptive statistics to make an inference, to draw some type of conclusion, to make an estimate about population values. Okay. So in order for this one to be inferential, it would have to say something like, based on the survey data of 140 houses in the area, the average price of all houses in the area is blah, blah, blah. Okay. Have to have something about taking a sample in there and then making a claim about a population value. Questions on the difference? Okay. 16, classifying some data here. We're given the number of French fries in each of 40 individual servings. So first of all, would that be qualitative or quantitative? It'd be quantitative. We've got numerical data there we're counting. Then we've got, is our data discrete, continuous, or neither? It is quantitative, so that means it will be discrete or continuous. So what do you think on this one? It's discrete. We're counting, so counts are usually discrete. And here we're thinking like we're just counting how many fries we have. We're not going to get crazy and say we've got like 13.25 fries. I know sometimes you do just get the little pieces, but this one, since we're counting, we would call it discrete. Okay. And then what about the level of measurement? We've helped ourselves out because we said it's quantitative. So you can remember that that means it's got to be one of the last two, interval or ratio. So the way we decide between these two is we think about what 0 means. If we had a serving of fries that had 0 fries in there, what does that mean? I mean, we really didn't have any fries, right? It was empty. Okay? So 0 actually means nothing. So which one? Ratio. If 0 actually means 0, but 0 actually means nothing, then it's ratio. If 0 is just a placeholder, and then it's interval. So that would be like when we're thinking like degrees Fahrenheit. Okay? I'm on degrees Fahrenheit, 0 degrees Fahrenheit's not the beginning of the scale, right? It doesn't mean no heat, because you can go down negative below it. 0 is just a placeholder there. So degrees Fahrenheit would be interval. This one's ratio. 0 fries actually means no fries. Okay. Questions on that one? Okay. 17. We got the number of gold medals each country won in the last Olympics. Okay, so would that be qualitative or quantitative? That's quantitative, we're counting again. And then what about discrete, continuous, or neither? Yeah, that's discrete again. And kind of getting a real similar problem here. Okay. And then, since we know it's quantitative, it's either interval or ratio. So we have to think about what does it mean if a country won 0 gold medals? It means they didn't win any. So it's ratio. Ratio 0 actually means none. So that one worked out the same way. That's what happens when I let it give me random problems for us to do. We get 2 that are the same. Okay. Let me see what else we got coming up. We got one more that'll take care of most of the other. Here, just a reminder, continuous data is if we're measuring something. Okay? We can be more as precise as we want to be with our numbers. That's continuous. And then I think that with this next one covers all the possibilities. Pretty much. Okay. On this one, same thing, we're classifying. We got a survey response to the question, what is your favorite color? Red, blue, green, or orange. Okay. Don't let the numbers throw you off. Okay, that's not what the data is going to look like. The data is the names of the colors. So is this qualitative or quantitative? This one's qualitative. We just got labels. Okay. So would this be discrete, continuous, or neither? Neither. If you have qualitative data, it's always neither. Okay. And then on level of measurement, since it's qualitative, we know it's got to be either nominal or ordinal. So here we have to think about, okay, so our data is different colors. Do we have like a built-in automatic ordering system with color? No, so it's not ordinal, it's nominal. Okay, so that's the difference between these two, is if we have a meaningful order, it's ordinal. If we don't, it's nominal. Okay. Questions on that one? On any of the classification? Because I think that's our last one. All right, good deal. 19, we've got a frequency table. It says determine the relative frequency for the 4th class. Okay, so 4th class is just the 4th row. That's this one. Okay, it says determine the relative frequency. Okay, just the regular frequency is 14. But to figure out relative frequency, what do we have to do? Because we want the frequency relative to the whole, how many data values we had. So we need to, we got to figure out how many we had. So sometimes we get lucky, and we didn't on this one. Sometimes we get lucky and they tell us how many were in here. This one we didn't, so to figure out how many data values we had, we just add all these up to get our total. All right, so 14 plus 11 plus 12 plus 14 plus 10. I might get a total of 61. Okay, so for our relative frequency, 14 out of 61. And I don't think that'll simplify. I think that is simplified. I'm not gonna care if you here, just give me the relative frequency. I'll just say give me the relative frequency on the test. So you can do it as a decimal or as a fraction, doesn't matter. Questions on that one? Yes. You get every number.
Instead of 61, I thought to fix.
Well, let me double
Do
check.
you add up 14, 11, 12, 14, and 10?
Yeah, you add all of them. Yeah. Yeah, because we're trying to get the total, so you add all the frequencies up there. Yeah. You're kind of mixing it with cumulative a little bit. Yeah. Okay. Other questions? Okay. Okay. Number 20. Almost done. We only got 23. So we're on 20. All right, this one says, for the following type of data, would you be more interested in looking at the mean, median, or mode? State your reasoning. Okay. I know on Hoxie's are multiple choice. It won't be on exam. Okay. So it gives you mean, median, or mode, so I'd let that in because it asks you which one. But the reasoning part, I want you to be able to tell me. Okay. So we're given the salary of first-year teachers at a local elementary school. So first of all, we have to think about, would that data be qualitative or quantitative? It's going to be quantitative. And so since it's quantitative, that narrows it down to these two. The mode, if we have qualitative data, we use the mode. And that's all you have to say for your justification, is it's qualitative. Okay. With quantitative data, we're either going to use the mean or the median. And the way we decide is by whether or not we expect to have outliers in our data. Okay. So here, they're first-year teachers, and they're all at the same school. So do we expect to have any outliers in that data? Probably not. Okay. They're probably all going to be paid around the same, okay, because they're all new and they're all at the same school. So here we have quantitative data, no outliers. Which one should we use? Mean, good. Yeah, so here I would say we have quantitative data. We have no outliers. I'm happy with that. If you pick the median, that would be when we have quantitative data and we do expect outliers. And then again, if we have qualitative data, we pick the mode. And the reasoning behind that is that, remember, outliers mess the mean up. The outliers draw the mean toward wherever they are. On that one? Okay. 21 gives us a graph and gives us these three numbers on the graph, letters. Says which one would be the mean, which one would be the median, which one would be the mode. So on these, I usually start with the mode, because on the graph, which one's going to be the mode is by definition, it's the tallest point on the graph. So here B is at the tallest peak. So B would be the mode. Okay. Then I usually do the mean, because by definition, the mean is going to be the one closest to any outliers we have. Okay. So what would we call this shape? skewed to the left. And we got the skinny tail on the left. And why is it skewed to the left? Because what's over here? That's where we have outliers. Yeah, good. Okay. So the one that's going to be closest to those outliers is A. And then the median is C, because that's the one that's left. And the definition says it divides the area under the curve in half. Okay. On that one. Okay. Two more. $22 gives us a probability distribution. It says find the standard deviation. This is the one that's, I just saw the number it gave. I'm sorry, I got distracted. This is the one that's a little bit more tedious. Okay, we really have to do two calculations here. Because first we have to find the expected value, and then we can find the standard deviation. What distracted me about the numbers on this problem is this is a terrible problem because all the probabilities are the same. Okay, so let's go through the motions. Okay. First, we would need to find the expected value. And in the formula, it's labeled as mu, it's labeled as the mean. So we've already done one of those. We're just taking each outcome times its probability and adding those all together. This one's not exciting. What's our expected value? You may do it. 4. It comes out exactly like that because it's all the probabilities are the same and it's the middle number. There's our expected value. Okay. And then for standard deviation, let's see if I can remember the formula. It is square root of the sum of each outcome squared times its probability minus mu squared. So here we take each outcome and square it, and then multiply it by its probability. And then subtract this number squared, and then take the square root. Okay. So unless I'm just thinking about it wrong, this is going to be boring. Oh, I forgot one, sorry. Square root of 2, yeah. So square root of 2, it says round to one decimal place, so 1.4.
All in our class.
Yeah. Yeah, it's okay. Yeah, it's best if you write it down in case something goes wrong. Okay, but if you get the right number, you're gonna be okay. But if you write it down, then I can see what you're doing, and that way I can give you some partial credit if it goes horribly wrong in the calculator somewhere. At least write down what expected value you get, and then give me the standard deviation. So at least give me those two numbers. Other questions on that one? That's the messiest formula we have. That one. Messiest formula we have all semester. So that's what I think. All right, one more. That's one. It says a quality control inspector has drawn a sample of 14 light bulbs from a recent production lot. The number of defective bulbs is 2 or more. The lot fails inspection. Suppose 20% of the bulbs in the lot are defective. What's the probability the lot will fail inspection? So, is it binomial? Because the bulb's either good or bad. I need NP and X. Got a sample of 14 light bulbs, that's N. We're looking for, if we just pick a random bulb, what's the chance it's defective? It's 20%, 0.2. And then this one's a little bit trickier than the last one because it says if the defective bulbs are 2 or more, the lot fails inspection. So we're looking for the probability X is 2 or more. That's greater than or equal to 2. So to find this, if you're using the formula, okay, we would need to find the probabilities of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, add all those together. That's not what I suggest. Okay, you could kind of work it like we're going to work it too. But remember, if our sign's pointing the wrong way, we're wanting to use the cumulative binomial here. Okay? But cumulative binomial gives us less than or equal to some number. So to flip that around, we subtract it from 1. So we're going to do 1 minus the opposite. So what's the opposite of greater than or equal to 2? Less than or equal to 1, that's a good answer. Okay, you could say less than 2, but then we still have to adjust that. So we eventually end up at less than or equal to 1. That one's as tricky as they get. They're not all that tricky. Okay, so then we can go to our table. We're going to the cumulative table this time. N of 14, P of 0.2, and we're looking up 1. N of 14, P of 0.2, look at 1, we get 0.1979. I'm going to do 1 minus 0.1979. What'd you get? I got 0.8021, yeah. They're not all that tricky. Remember, if we ended up with less than or equal to, all we'd have to do is look it up in the cumulative table. Don't always have to do this step. That was one of the trickier ones. Questions on that one? Feel okay with it? Yes.
Is there going to be 23 questions on the test?
It'll be somewhere in that range. I don't know. It won't be too much longer or shorter than that.
And we'll have the whole class time.
Yeah. Yeah, you won't be rushed for time. So. Okay. All right. you didn't get on the sign-in sheet, we'll get on there before you leave. We'll track it down and move it up front, and that's it. I'll see you Thursday. Grab the sheet back here. Hey,
So I'm gonna ask, how do we have access to the tables on the test?
I'll print them. They'll be printed, yeah.
Okay,
Yeah.
thank you.
Yeah, you'll have the pages you need. Yeah. Yeah. Go ahead.
You're not gonna have calculators for us to use, are you?
I might have a couple, but the downside of that is you might not know how to do standard deviation on it. Or you'll be able to do, you'll be able to use other stuff.
Alright, I'll try and borrow one of my brothers.
Okay.
I just don't have one.
I got you. Yeah.
How did you get the PX?
MP next.
Yeah, I was trying to understand it. I know how you did N and P.
Oh, and
but
how did I get the
understand-
X?
Yeah, I understand that part, but how?
To get from there to here?
Yeah.
Okay,
Why
so,
did we do that?
all right, so the reason why we did it was because our cumulative table only gives us less than or equal to whatever number we look up.
Okay.
And then the how we did it, so we want to do 1 minus the opposite so we can flip the sign.
Is that just a rule? That's why I was.
Yeah, it's column rule.
Okay, all right.
But the way we ended up with what we did, right? So greater than or equal to 2 means 2, 3, 4, 5, 6, all the way up to 14. So the opposite of that would be 1 or 0. Right? Does
Okay.
that make sense?
Yeah.
Okay, so 1 or 0, that's less than or equal to 1.
That makes sense now. All right.
Okay, good.
All right, thank you.
Yeah, no
I'm
problem.
sorry.
That's okay.